Okay. So welcome everyone to the Palisades Recovery Coalition meeting on fire technology. Again, we will record this meeting so that people can refer to this as the recovery unfolds. As I'm sure you all know better than anyone else, there is a lot of fire tech out there on the market that's developing rather quickly. And I have had the good fortune of meeting with the 4 people who are on this call today to present. So I asked them to come and present to the community today as just a starting point. I think we're going to learn a lot from these 4 people. We'll have time for Q&A, but I think it will give us the direction to go from here forward as we begin to rebuild this community in a resilient way. I've put a disclaimer into our chat. I just want to make sure everyone knows that this is not an endorsement on the part of the Palisades Recovery Coalition. This is, just as we do with everything else, a process of giving information to the community and having them be able to be aware of new resources, new opportunities, new theories, new ways to rebuild in a resilient way. And I'm very happy to be hosting this call. I've been talking about it for months, and I think, again, this will just be the beginning. So 2 of the people who have joined us today were introduced to us by the Office of Senator Ben Allen. They are joining us from Tel Aviv, so I have to thank you guys for being here at night for you. I'm excited to hear from you. And 2 people who are on this call are here, I think, locally in California, Jesse and Chris McDonald, one from Strongwater, and the other is from Embers Protection Services. So I think you all have the PDF that I sent around with a little bit of a description of what they all do. David is from Water Dome, and Daphna is from Fire Dome. So we're going to hear from all 4 of them. They'll all give us a presentation of about 10 minutes, and then we'll do Q&A, and then we'll take it from there. So Daphna, if you don't mind, we will begin with you. You are Fire Dome. You are the beginning of this conversation. I have to say that we started to form this meeting, this presentation, after having spoken to you. Just to let everybody know, Daphna has had the benefit of being in the community. She actually walked through the Marquez area, and she sort of formulated a theory as to how they could help not only protect homes, but protect perimeters. So I'm super excited to hear from everybody, but I'm going to throw it to Daphna first. Thank you so much for joining us again.
Fabulous and great to meet everybody, and thank you for joining. I think this topic is super important, and please feel free in a little bit of Israeli way, but if you want to stop me in the middle of the presentation as well for something that can clarify for you, just feel free. I'm going to share my screen. Oh, Miriam, you need to give me permission to share my screen.
Yep, Miriam? I was doing that just as you started to. There you go.
Okay, let me try again. Perfect. And then. Okay, you all see my deck?
Yes, yes, we are.
Okay, wonderful. Okay, I'm going to start with a video. It's a couple of minutes long, but I think it's worth it. Last time we met, we didn't have the technology.
Wildfires are a growing worldwide reality. Hotter, longer, wind-driven seasons.
You can hear the audio.
You need to act in seconds.
Yes, we can hear the audio.
Spreads to you. Meet Fire Dome, Wildfire Resilience as a Service, an autonomous system that detects, decides, and acts in seconds. At the heart of Fire Dome is an autonomous AI-powered electromechanical launcher that's always on guard. The system is always scanning for fire threats, using advanced computer vision that combines thermal, radiometric, and visual imaging with data from wind, humidity, and acoustic sensors. When fire is detected, Fire Dome responds in seconds. Smart capsules seated in a uniquely designed cradle are filled with water or eco-friendly fire retardant. In seconds, the capsules are launched and activated mid-air, exactly where they're needed. The off-grid launcher rotates 360 degrees and dispatches capsules up to 1,000 feet away. And behind the hardware, Fire Dome's AI algorithms are trained to understand your site, detecting spot fires, prioritizing threats, and adjusting trajectories for wind. When a risk arises, Fire Dome takes proactive measures within seconds, creating a fire break to defend the site and coating your valued assets with a protective layer of retardant. And in real time, when spot fires ignite, FireDome detects danger instantly and auto-launches smart suppression capsules, fast, targeted, and efficient. FireDome acts with safety first. The AI algorithms pause the system when humans, animals, or aircraft are detected, and manual override is possible when needed. Containerized delivery and rapid installation. A cover that blends in. FireDome is autonomous, with off-grid power, water, and communications. The system has been field tested for months with excellent results. Remote health checks and automated self-tests confirm readiness, while clear status dashboards keep crews informed. In September 2025, FireDome held its first live system demonstration, showcasing what the technology can do. In front of a live audience, the system detected multiple spot fires, launched smart capsules to suppress them, and even paused automatically when people were present in the area. Fire doesn't wait. FireDome always stays a step ahead. Let's put resilience in place.
Okay.
I wonder if we lost you.
But
Daphne, I think we've lost you. Okay. Assuming Daphne is having,
hi.
hi. Okay,
I
great.
don't know what's happened. Did you manage to see the video till the
We
end?
did. We saw the
Okay,
entirety of the
yay.
video.
Okay, so I have no idea what happened here, but I had a glitch. My Zoom stopped and now it's back. So what I was saying is the launcher is at the heart of the system. We're giving wildfire resilience as a service, a platform of resilience product, but the core of it is that we have proactive, preventive, and reactive layers. The first one, like it was explained in the video, when we know a fire is coming, the system awakens, the launcher rises, and basically creates a fire break around the area or in the locations that are needed with the wildfire indication from where it's coming from, and also covers the valuable predetermined assets with this retardant. Those capsules that you've seen, they can either have the smart capsules can either have retardant in them or water. When spot fires happen, the system detects it and aims the capsule directly on the spot fires to suppress them. So this is basically the only system that can give both the proactive defense and the reactive in real time. As a service, we are going to collaborate with other things like vegetation treatment, home hardening, and all of that. This is a supplemental shield that gives resilience to the communities. As an example, this is one of our customers' properties, and that's an analysis that was done by a fire expert that shows when the fire, one scenario of fire that's coming from the most likelihood area, what would happen without FireDome, and if we have FireDome situated here, and it creates this peripheral break and deals with the spot fires, basically the fire cannot go in. And again, going over the core components that were in the video, but I think it's important to linger at that a little bit. The FireDome launcher, which is totally electromechanical, it's no explosives. It looks a little bit intimidating from this beautiful picture, but it's quite big. But it's like a big slingshot in a way. The smart capsules, each of them has a small sensor that is attached to them. They are activated in the air. So after a fire event, we are going to come and clean up the area. The material is a very thin elastic material, kind of like a balloon. Doesn't happen anything when it falls on the floor. The retardant is an eco-friendly retardant. Sensors are multiple sensors and cameras next to the system that basically do triangulation to make sure that we have as many the most accurate result and the least false positives. This is all powered by an AI engine and an AI algorithms that basically make the decisions. That's the brain of the launcher, because in real time there's going to be multiple spot fires in various sizes, and this decision-making algorithm will basically prioritize the threats. So the launcher that turns 360 degrees can launch one capsule on one spot fire, to turn to the next, go back to the first one, and deal with them in the most optimized way to reduce the threat to the property, because sometimes it's better to have a few spot fires very, very low but active rather than suppress one and have the rest of them grow. All of this is autonomous and safe. So for that, the same AI algorithm needs to know when humans are in the area, if an aircraft is coming, fire service is there, that it automatically pauses. It's seamlessly integrated to the fire control room. So if the fire marshal or the fire chiefs want to pause the system, they can do that as well. And of course, with an app that I will show you in a second. And this, we kind of went through this, but this is the advantages. The holistic approach to wildfire defense thinks about it both of how do we do it without human intervention, self-sufficient, off-the-grid water, electrical, and communications. So if the grid goes down, if we don't have enough water, this has its own water tank, real-time autonomous detection, suppression, and protection, and also taking into account weather conditions. This mechanism with the brain, the AI, the same AI algorithms that I was talking about, the sensor, the wind sensor can give the data to the launcher, and the launcher adjusts the speed and the angle of the launch according to the weather condition and the wind condition in the same moment in the same place. So basically, while helicopters cannot fly and defend us, this launcher can still do its job in a very, very accurate way. And of course, for larger properties, there could be multiple launcher. Each launcher protects about 70 acres. About the service, a little bit, I touched it. It's all-inclusive, monthly service fee. So if it's a community of 40 homes, and this, a lot of people ask about the price. It's between $10,000 to $15,000 a month for a launcher. If there's 40 houses there, it's $200, $250 a month. And this includes everything, including the reports, the risk analysis, the survey, additional fire protection measures, maintenance, monitoring, and after fire event, we give the services, of course, to the launcher and bring it back to where it's supposed to be. So also includes all the initial capsules that are needed. This launcher has an automatic filling and loading mechanism, and comes with 3,000 capsules that are stored empty and filled with water on the go as needed. This is an example of a cover, but the idea is that the cover looks like a big utility room, and the exterior can look with a look and feel that fits the community. I'm rushing through because I know I don't have a lot of time. This is not yet fully designed, but the basic idea of what the app would look like. Each customer, depending on how many sites they have. In this example, it's a multi-sites customer, can see the alert that is going on, what is in the area, is the system active or just ready to be active, overall readiness, amount of capsule, the last maintenance, everything can be controlled, obviously, like we are used to with the app. If the system is launching, it will give it indication and live feed as well, and can also be stopped manually by the site owner. Each site is going to have a designated owner that can stop the system. And who are we serving? So you all know that we're serving communities and HOAs. Also, a lot of our customers are vineyards, wineries, resorts, utility infrastructures, campuses. The first system is going to be in the States, in California, in 2026. The first one in the second quarter is going to be in a test site. So we've done a lot of tests in Israel and a live demonstration, but we want to do that in California as well. Also, we were not able to do an encroaching fire in the test site that we're in right now. So we will do that in the States too. We validated the most important thing is that we can basically direct the launcher and aim and hit a specific spot fire that is not so big, which is the biggest technology challenge we had when we started this journey. And the first early adopters are going to get their systems end of 2026 and the beginning of 2027. That's less important. About the team a little bit. So I'm Dafna, I'm the COO of FireDome. I come from 14 years of entrepreneurship in construction tech industry. So I know very well how difficult it is to innovate with hardware, and I'm on a mission definitely to help with wildfire crisis. The two co-founders of FireDome is Gadi Benjamini, who is the CEO, comes from many years in the Israeli military, in intelligence and engineering. Adi Noor Pomerantz, who is the CTO, comes from SolarEdge. She's a doctor of material science, and we have an amazing advisory board from the multidisciplines that have to do with whether it's mechanical, Pini Jungmann, who was the founding father of Iron Dome, or Dr. Lori Morel, who was the former US fire administrator for the last administration. We have people from the insurance industry, high-tech industry, and such. And I'm going to stop sharing now. Do we do Q&A now, Miriam, or at the end for everybody?
I was going to have everyone present and then we'll do Q&A. That was excellent. Thank you, Daphna.
Okay.
Thank you.
You're welcome. Thank you.
Okay. Next up, we'll do Chris McDonald, Embers Protection Services.
Thank you, Miriam. Appreciate it.
Our pleasure. Thank you for being here. I'm going to make you co-host so that you're able to share your screen.
Oh, great, great. Okay. Okay, thank you guys for being here. I'm Chris McDonald, the CEO of Embers Protection Services. This is kind of a little bit about what we do. We install wildfire defense systems that can protect individual homeowners. We do multifamily projects like condos and apartment complexes, and we also do full-on communities. Recently, we've been involved with several communities, including one at North Beverly Park, where we are doing an entire surround of perimeter defense for the community that deploys a eco-friendly fire retardant out autonomously through several ways that we track fire. One of the ways that we track fires is through satellite information. Our technology extracts data from NASA and U.S. Forestry Department satellite information. We compare it to our known coordinates of homes that we're protecting, and our proprietary software creates a distance to the 100th of a mile on how far the fire is in relation to the property. Depending on how close the fire is to the property will depend on the sequence of operation that our system will take on. Initially, what is done is a fire retardant is deployed around the entire property or community. Essentially, that is a hard piped infrastructure that is installed, that we have tanks on site full of an eco-friendly fire retardant that is ready to go at any minute. This product can be deployed proactively in every 3 or 4 months, or it can be deployed when fires are imminent. The deployment is autonomous, so there's no human interface required. It will deploy automatically depending on several factors. One is the satellite information that we receive. We also have heat sensors located around the property that we set a temperature threshold. And when the temperature gets above a certain level, that will also deploy. And we use infrared cameras. We have been installing these systems since 2020. We have a little under 100 installations in the field in several different states. We have 100% success rate, including 4 homes in the Palisades fire and 14 in the Franklin and Palisades fire in Malibu. A couple of them you're looking at right now. On the left is a home in Malibu that survived both the Franklin and the Palisades fire. As you see, the little fire icons were homes that were destroyed. And essentially the fires were coming up the ravine and stopped where the fire retardant was deployed around the property and essentially continued on around the property and up the hill. After the Franklin fire, the fire department knew this was a safe location to stage their equipment and so did so. And the Palisades fire, they used it as a staging area to bring containment crews up into the hill. So part of our system is the deployment around the perimeter, but we also know that most fires, house fires at least, are initiating by airborne embers. So embers are a very big concern to us. And so what we're doing is a dual defense system. One, the perimeter deployment is going to stop encroaching fire radiant heat from getting too close to the property. And then we have a structure defense system that's going to prevent airborne embers from starting initial fires on the roof or near the structure. Part of our roof system not only defends the roof, but it oversprays into trees and into vegetation that potentially can be used for kindling for a fire. On this perimeter, like I had mentioned, it's an eco-friendly long-term fire retardant that can last for several months, but typically most of this is used when fires are imminent. And on the roof, we're initially using water systems. That's basically we're using several different sources of water. We're using municipal water at first. We've developed a constant pressure system in our equipment that allows us to use fluctuating water pressure. We also have flow sensors. Oh, and that includes, I'm sorry, a variable speed pump, a pressure tank, and a pressure sensor that will maintain constant pressure. We have a flow sensor that if the volume of water is cut off to the property, we can switch over to, like in Southern California, it's mostly swimming pools, and we can utilize that body of water. But we also have the ability to install cistern or above ground tanks. And third is a tank full of AB firefighting foam. And the foam is a great product for structures because it doesn't do any damage. It's not corrosive. It doesn't stain. Unlike the fire retardants, it could potentially do damage if left on the structure for a long period of time. So we have this dual defense system. We have constant pressure built into our equipment. We have the option to use multiple sources of water and then into a fire suppression tank. We monitor through satellite information, heat sensors that we locate around the property that are hardwired in, and infrared cameras. So you're getting all of the best technology to be able to detect fire. The picture on the right is a Palisades survivor on Turquesa Lane that essentially about 90% of the homes burnt down. We know this is proven success. We had several of them survive. We've never lost a home. And these essentially was the big true test of all the serious, most severe conditions that we had during the Palisades fire. No low water pressure. Well, first of all, no electricity, which we always have backup power. We either provide it or we tie into the existing backup power on the home, which could be either a generator or solar batteries or any type of heavy duty type of backup power. Then we essentially lost water pressure, which we can maintain pressure through our system. We lost water altogether, which then we switched over to the pools and then to the foam tanks. And then we lost natural gas. So all of these things happen on top of having heavy, strong winds and all the radiant heat in the area. Our homes survive without any type of fire or heat damage. We use a holistic approach to this. So we're not only doing our autonomous systems, but we're also making sure that the home can defend itself in other ways. Defensible space is crucial. We do fuel mitigation, the right selection, the recommendations of certain types of plants, the right placement, and the right maintenance to make sure that things aren't overgrown and overhanging roof lines. Tree canopies aren't connecting to each other to create a domino effect all the way to the structure. So there's a lot of things that go into this, and defensible space is one of the most important. And then we do home hardening mitigation, which could be new ember and fire resilient vents, gutter guards, the type of windows that are on the house, type of roof material. We have fire retardant sprays that we can spray on wood decks, wood eaves, anything wood patio furniture to create a fire retardant wood. And then we do obviously our exterior fire suppression systems that we have a dual defense. We have constant water pressure. We have multiple sources of water and then foam and then reliable backup power. Our technology that we developed, like I had mentioned, was using satellites. We're using cameras. We're using heat sensors. We create a wildfire map specific to the homeowner's property. We put 1 mile rings around it with different danger level zones. And depending on where the fire is coming from and where it's at will depend on how the system operates. We install a control center at the house, along with the hard piped infrastructure around the perimeter and on the roof. We talk to our control centers bi-directional. We send data packages, and the control center talks back to our software, essentially through satellite communication. So we're installing a satellite communication at our control center so that we don't have spotty cellular reception is usually in the Palisades to begin with, and then adding a fire on top of that, it creates an unreliable communication source if you're trying to use cellular. We do have an app, as you're seeing right here, and that even if the homeowner cannot get on the app, that doesn't matter, that because the system is autonomous. We at our offices monitor this similar to like an ADT alarm company. We essentially do not have to press any buttons unless we want to override it into a manual mode. But we're using satellite communication at our hub, and we're communicating through satellite to our control centers. The map is specific to the property. We provide wind conditions, humidity, temperature, so that we can give red flag warnings on certain days that might be more susceptible to fire, just to have the client be more aware. But initially what's happening is when fires get within a certain distance of the property, typically about 5 miles away, alerts will be sent out to the client, whoever they decide to sign up onto the plan, that to pre-warn them that fire is within range. It's not quite super serious at this point when fires are 5 miles away, but we want them to get the mindset that you may have to evacuate fairly shortly. Any new coordinate that we receive that's closer than the one previously, a new alert will be sent out, obviously warning them that fires are encroaching, they're getting closer. So that's really important for us. We have all seen the news footages of the Palisades log jam of cars where the bulldozers had to come up and clear them out. Our goal is to get our clients out safe, more efficient, a lot quicker in advance of all the other neighbors that are essentially waiting to the last minute. Like I mentioned, we do have the constant pressure system. There's no user interface required, and backup power is essential, and we do include that. Little illustration of the different ways that I just spoke about. We got the satellite information, cameras, heat sensors. It's fully autonomous, and we use eco and pet-friendly products. So, even though our products are very effective, they're not going to have the footprint on the environment like a Phos-Chek would. That's essentially fairly toxic to the environment. It just kind of shows you that our software in the cloud is calculating where fires are in relation to our properties. We're using satellite information to get those coordinates. We're doing a bi-directional communication to our control panel, and we're receiving information back. The control panel shares information with us, like the temperature of the heat sensors, what pump is on, what the pressure of the water is at that current moment. And so it's a very valuable piece of mind information that we're receiving back from the actual control center as well. The image on the right is an example of an email or text that's sent out warning the client that, the danger level, this one's an extreme, the confidence level of the information that we're receiving, and then the distance to the 100th of a mile in terms of the proximity of the fire. Control center, it's a NEMA 3R rated control center. It's thermostat and temperature control with a thermostat and fan. Again, bidirectional. We're using satellite information. We do use a VFD, so we have like soft starts and stops of our pumps. That helps with the power when we're trying to pull and start these systems. We do have a patent on the system, which is only important for, we're not patent infringing on anybody, so that we're not going to be a system that's going to be taken off the market eventually. There's a lot of patent infringements going on right now. And we do build these panels in a UL lab. So for safety, reliability, inspections, plan checks, all of this is very important. We're using Allen Bradley components. So very industrial grade. It's built to withstand high heat, high wind, high vibration. There's a one-touch screen that can be has all the functions as the app. Typically, that's used for us when we do a 6-month service visit. So part of what we're doing is every 6 months we're servicing the unit, making sure everything is operational, and that's part of the monthly plan. And then on the right, you see that the way that we're building these is very clean, industrial style, and something that's going to last. Kind of a comparison to some of the competitor stuff out there. A lot of people are doing yard sprinkler things and this calling it a wildfire defense system. So, we feel like there's not much competition in terms of the quality and the strategies and the technology that we're putting out there. Wildfire map, just a little bit of a closer view. There's 3 different style maps the client can use: a satellite, more of a Google map, and then a topography map. On the left is information that's being given back from the control center, be essentially on the app, letting the homeowner know or the client know like what danger level you're in, what the miles is to the fire. You can go into a manual mode if they so choose to. And there's a panic button essentially, which is the emergency button. That emergency button is on the app. It's at the control center. If for whatever reason our system hasn't turned on, which we've never had that happen yet, but we put fail safes in place just in case. So if there's an instance where there's a car fire or a house fire next door and you want the system to operate, there is a panic button to press. Pump status, this is information that's being shot back to us through our control panel, just letting us know what the pressure is of the water, what pumps are on and off. Valve status, similar information, just kind of giving us the peace of mind that things are working correctly. Our temperature sensors, they're air temperature sensors. They're very accurate. They go to the 6 or 7 decimal. We can pick up spikes in heat from hundreds of yards away. This is a great fail-safe to the satellite. Plus, it's also good for initial fires that start in the general vicinity of where our system is installed. And arson or a house fire in the neighborhood that got from a wildfire or potentially from, a kitchen fire that got out of control. This is a great tool. And then we have the actual cameras as well that can monitor. For new construction, we have a very clean installation, so you're not going to see any piping on the outside. But again, this kind of gives you a kind of a comparison of a retrofit. On the left is how clean we can install the system on the side of a house. On the right is kind of what people are doing. Because we're using pumps and powerful pumps, we don't have to use multiple pipes. All of our heads go off at the same time. There's not a zone situation that's going to go from one head to the next. So that's very important in terms of what we feel is the best strategy to protect homes from airborne embers. Essentially, what you're looking at is a blizzard storm of hot coal and ash, and sometimes roof shingles and things being flown around. So we want to make sure that the whole system is working at the same time. Our roof heads essentially live in a housing that's on the right, stainless steel, powder coated to match the roof color. We're mostly concerned about effectiveness, but aesthetics is a close second. So we want to make sure that these look good on the structures as well as function. The heads are designed to withstand wind. They shoot a 50 to 60-foot radius, have a dual nozzle application that spins around and does obviously coat the roof, but it gets into the trees and to the bushes around the entire structure. Kind of showing you a new construction. We provide flashings for the new construction roofing company to waterproof in, and then we put our housings over the top. Because they do shoot 50 feet, we don't need to put a lot of them on the roof. This is about a 5,000 square foot home. It has three. So typically you're going to get between 3 and 6 on a home, and obviously one on the ADU. We also, in new construction, put little eave soffit nozzles up into the eaves and soffits. They're mostly directed to protect the most vulnerable part of a new constructed home, which is the windows and doors. So we're placing these in strategic areas around the structure, up into the soffits. They shoot down a flat fan wall of water in front of the windows to protect the horizontal wind from blowing embers into the window and potentially breaking them. It also helps with the transfer of radiant heat into the home as well. Perimeter retardants, we have two retardants that we use. There's Komodo and Phos-Chek. Typically, Komodo is what we recommend. It's organic, plant-based, biodegradable. And then some clients will choose Phos-Chek because they're familiar with the brand, but we always pre-warn them about the toxicity to the environment. Kind of showing you a layout of how this is installed. We have a perimeter in the blue that's deploying a one-time long-term fire retardant. And then we have a roof system that's defending the home from airborne embers and initial fires that start near the home. We do full-on risk assessments. So we work closely with many insurance brokers and carriers that understand that what we're doing is lowering risk. So we are getting people off the FAIR plan onto real policies. And we also are getting people premium discounts. Entire communities that get together to do this have a lot of leverage with the insurance that they are protecting, lowering risk for the insurance carrier. So the underwriters are more willing to write real policies that matter. Brand guard vents, we use ember and fire resistant vents. When we're doing new construction, we want to make sure that these vents are installed initially. They have a screen, a 16th-inch stainless steel screen behind the baffle. You can paint the baffle to match the color of the house, and it has intumescent strips in there that will expand and close the vent up if the radiant heat gets above 300 degrees. Leaf gutter guards, pretty self-explanatory. What we're doing is keeping fuel out of the gutters, making sure the basins are clear and not having a dry kindling for fire. These airborne embers will cascade over onto the roof and find any area, any dry material that it can use for initial fire. Fire treatment plan. So we do these pre-applications. New construction, we go in and spray the framing on the house. We create a fire retardant wood and insect retardant wood. Plus, we have the ability to spray existing homes with the wood eaves, wood decks, patio furniture, and things of that nature. Defensible space, we're very keen on defensible space. So we go by the HIZ zone rules. You got your 0 to 5, which is zone 0. We're looking at non-woody plants, more of a water-based type of vegetation that's going to be a lot more resistant to airborne embers starting fires. We look at, the 5 to 30 tree canopies not overhanging the roof line, making sure that they're not within 10 feet of a chimney. So we go by all these guidelines to really ensure that the fire doesn't initially start in someone's backyard and then spread to their structure. What I'm going to do right now is I'm going to show you a quick little video as well. So I'm going to stop sharing here. I'm going to share again. So right here. And this is a client in your neighborhood that survived the fire. So I just want to play some of this and
So Chris, I want to tell you that there's, so far as I can tell, no audio on your video.
oh, you can't hear it? I'm sorry.
If others can hear, please nod. Josie, can you hear?
No?
No. And
Okay.
I also want to say, we've got only until 11. We've got 2 more to go. So
I can send you a link on that.
yeah,
So, and you can share that,
I
when
definitely
that
will.
comes about.
Yeah.
But it's just one of the clients explaining to everybody that, we were why the home survived, everything around it burnt down, and we end up helping save the 2 neighboring homes as well. So it's kind of a proven
Perfect.
success story.
Okay, and if you want to drop the link in the chat, people can pick it up and hopefully hear it, on their
Yeah,
laptops
absolutely.
when they
That'd be
play
great.
it.
That'd be great.
And I know that we're only as resilient as our neighbors, so that'll be important. I'm going to move on to Jesse and Strongwater, but I want to point out at the end of you and Daphna's presentation, and we can do this in Q&A, but it strikes me that Daphna's presentation is about a perimeter resilience. It's about a community resilience, and yours helps individual homes be resilient. And so that has a compounding impact on the community. So
Well, yeah, we also not to interrupt you, but we also do entire communities as well.
okay.
So, like for the North Beverly Park project, we have 5 stations that are off grid around 20,000 linear feet,
Okay.
protecting the canyons from fire getting into the neighborhood. So,
Okay, and I think Jesse's going to get into this too, but something to just think about or talk about. There's there's individual home resilience, there's community resilience, and then as you very well brought up, there's the insurance factor. And I think insurance is going to be looking not only at individual homes, but also communities and perimeters that can be protected. So we'll get into that. We'll hear from Jesse and then David, and we'll go from there. So Strongwater, take it away.
Thank you so much. I appreciate it. Similar to, let me see if I can move my screen. Are you able to see that?
Yeah, we're able to see it. Perfect.
Yeah, so my name is Jesse Kay. I'm one of the partners at Home Dome. The company was founded on the backbone of one of the other partners, Fire Protection Techs. He's been a firefighter fighting fires out of Oregon for about 15 years. A lot of his fellow firemen were getting sick on the red stuff, Phos-Chek, and some of the other toxic materials. And so he developed a similar product to Komodo, but I think it's a bit more effective. It's a California Proposition 65 compliant, non-toxic, biodegradable water additive. So it multiplies the effectiveness of water. And he's been using that with a proprietary pumping technology on his fire trucks for about 12, 13 years. I come from a background of ag tech, agricultural technologies and greenhouses. He and I are both environmental activists. On the backbone of the Palisades, I called Jeff and I said, we need to develop a home protection product, specifically using strong water gel. And we developed a company called Home Dome. We're going in the Palisades right now into a home that will be active and available in about 6 months for hopefully next season's deployment. Similar to Embers, we are being installed both in new construction and retrofits. We can also go in community perimeter systems. One of the beauties of our product, which I'm going to skip down here, we're on the 3rd generation of product called Guardian. One of the beauties of Guardian and all of the strong water gels is that we are a modification gel. So when we're combined with water at about 0.5% and pumped through a system at about 120 psi, within the pumping system, it acts like water. And when it leaves the head or the nozzle, it turns into a gel and it thickens and hardens and it sticks and stays. So about 95% of the product that hits a structure, whether it's a roof or a side or a plant or landscaping, will maintain its moisture for between 8 and 10 hours. And so we're a little bit different than the 2 other companies in that one, we're an all-in-one system. So we're sort of like a Generac generator. We sit in a box. It includes about 250 gallons of strong water gel. Our computer system, 30 kilowatts of battery is within the box itself if the home doesn't have an on-site battery system or solar. And so we've got about 30 to 60 hours of on-site battery storage. So in the event of infrastructure collapse, like we saw in the Palisades, we can run completely autonomously and completely independent of the grid without any input from any outside source. One of the beauties too is that if we come in early enough and we work on a new construction home, we can talk to the homeowners about putting on-site water storage, so either a cistern or an on-site water tank, or we can pull from pool water, and we make that water source between 8 and 10 times more effective. So 10,000 gallons of a pool or on-site cistern is effectively about 80,000 gallons of water. But problem with water and foam that a lot of people are using is that foam falls off after about an hour or two, and water falls off immediately. And so you only actually capture about 5% of the humidity or the moisture content of the water itself. Whereas with a gel, it hits, it sticks, it stays, and it holds moisture for about 8 to 10 hours. And so the way our system's working right now is when we are installed on a house, we put our sprinkler heads. If it's a new construction house, we'll actually put our system within the house itself, and we will strategically place the heads on the roof and then around the house itself into between 6 and 8 zones. The roof is generally the first 2 zones, and then the rest of the house is the remaining 4 to 6. And so we have ember detections as well on the roof. And so as we're picking up embers that are being blown on the house, generally zones 1 and 2 will deploy. And so that's roof coverage for ember protection. So we'll hit the roof, turns into a gel, and it establishes about a 3/8 of an inch moisture barrier. So when embers hit, they're put out. And as that fire comes closer to the house, if we detect direct fire impingement adjacent to the structure itself, the remaining zones will actually envelop the entire home in our gel coating. And so we can withstand about 3,000 degrees of direct fire exposure for 10 to 15 minutes. So you can take a blowtorch to the structure of a house for 15 minutes. The gel will protect it, and then ideally the home is saved, the fire moves beyond the house, and you can wash it off with a saline solution or a high pressure washer, and all the gel will fall off into the ground. It gets diluted with water, or rain, or a sprinkler system, and then your kids and dogs can go back and play in the yard again the next day. Part of our computer system is similar, is that we detect the fire. It can be remotely activated from your cell phone with Wi-Fi, cell phone connection, and soon we're going to have a plugin for a satellite connection as well, depending on the homeowner's preference. You can do a manual override, and if you choose to manually override the automations of the system will warn you that you're overriding the system. And so what's going to happen is the computer and the database will establish the peak risk of the property, with changes. Sorry?
That might have been a glitch with somebody's mute. Keep going. We're listening.
Yeah, so the system will establish peak risk window because our gel, if it's just coating the roof, it's got about 60 hours of protection. And if it's coating the entire home, we are recommending and suggesting and consulting on installs for between 30 and 40 hours of protection. So if you're coating the whole house, we cycle on and off every 10 hours. So we'll spray the house, it'll get a full coat. The system will shut down for 8 hours because it has the moisture barrier that it needs. It can activate again in 10 hours, or it will, and then it will shut down again for 10 hours, and then it will turn on again a third or fourth time, depending on how much water storage is on the property. We are not connected to a municipal water source. We're actually against it. So as long as you have your own water storage. And the reason for it is that when you have all these homes with all these different fire resilience products, we're actually collapsing the infrastructure when the firemen need it most. And so we pull from a pool or a water system. But if you've got all these homes, like our home has a 2-inch water inlet on it from the street. And so if you have 30 homes all pulling off of a 2-inch water, spraying their homes with sprinkler systems, you're increasing the rate of risk for the remaining homes in the community. And so people will turn it on, they'll leave, it'll be on for 10, 12, 14, 24, 48 hours. And now the firemen who need it to fight fires where it's most needed don't have access to substantial water pressure out of the hydrant system. And that's under the current system. I know that like Workwell is working on having a second system, one for firefighting and one for homeowners. But until that happens, right now we're all sharing the same infrastructure and pressure. So yeah, we have a single pump. It's about a 5 horsepower pump pushing to the house. We can create fire lines. If you have a large enough property, we can add on ADUs. If you've got a bigger than about a 6,500 to 700 square foot house, we'll have plugins for our system that will plug into the side of the original box. So it's one brain covering an entire property. For communities and HOAs, we can do multiple deployments of boxes, and generally a deployment around the property. And the way that we design those is we have either telephone poles, light poles. We can do perimeter systems where we spray a mist in the air using strong water gel. That misted spray will get carried by the wind upwind of whatever that community is, depending on the zone, coat everything in a thin layer of strong water gel. And then as embers are hitting the community, they'll follow the same wind pattern. And so that will hit our strong water gel. It's clear. It's a little opaque, but wash off. No staining, no toxicity. Proven gel over an extended period of time. The CEO is Jeff Denholm. He's a good friend of mine. We've been friends for about 7 years. I've been in fire tech, and then Jake is our battery storage and water tech engineer. And between the three of us, we've got a beautiful technology. So I think that's it for now.
Perfect. Thank you, Jesse. You make a very good point about municipal water sources. I think, as everyone on the call knows, one of the problems in the Palisades was that there was not enough municipal water. So it's, I think, an autonomous system is something we probably are going to be listening for. Okay, so we had a late addition, David Shavit. I'm going to hand the floor to you. Please keep to the 10 minutes if you can. I have a hard stop at 11 and I want to have a chance for Q&A from the audience, but thank you for joining us, David Shavit. Take it away.
Hi. So first, let me tell, do you see me? Okay. So first,
Yes.
before the slides, let me tell you the headlines. I think what happened should not happen again. I think it was demonstrated that the technology that is available today cannot do the job and something new has to be done. Massive wetting was demonstrated for dozens of years that it would make the job, but it will make the jobs not in urban area where the system is designed for showers in the morning and not for the amount of water you need for the massive amount of water you need for firefighting. So our novel solution is to realize that the water distribution system in the community is the critical problem. And what we do, we manage this water distribution system in a way that we checked tens, almost 100 village places, that communities, their water distribution system. And we claim that we can, if we control it, we can have enough water allocated to each defense point, and without letting the pressure to collapse. Our system works by push of a button. The whole village can be, the whole community can be defense. It's like a miracle that put suddenly rain when the fire is going to come, or like you putting hundreds of firefighters engine immediately to start to help you. And it's important that you can make it immediately because you want to avoid the urban wildfire to start. Because when that starts, it's very hard to stop it. So what we have is operational, effective, and I think the most affordable system. But I don't know well all the others, so maybe I'm wrong. But the way it looks to me, we are the most affordable. So I would like to share my slides. It would be telling what I said, but a bit more in details.
You have screen share, so go ahead.
Okay. So just give me feedback if you see it. You see the slides?
Yes, we can see it. Yes, thank you.
Okay, that's flying above Alphabet. I flew before the fire, I flew above the fire, and it's really the thing to see what happened. People like to live in the green area, or in your case, it's maybe less green, but a beautiful area with the view to the sea, and you want to remain that way. But of course, with that comes the fear of fire, and definitely you know that feeling more than anyone else. And the feeling and the fear from the fire is reasonable because the amount of structures, home that was destroyed is increasing exponentially. And you can see this is the last January fire. And with that comes the fact that there was a very good alert by meteorology. They detected the fire immediately. A lot of homes were with the last code of protecting the home. And they deployed all what they have, and it didn't help. So something is wrong with what is done today. We have to change the method. And one of the things that previous people spoke as well, and I think it's important, we have to avoid the urban fire from starting. When that starts, it's very hard to defend from that. So it has to be a kind of immediately defense that is initiated when the fire comes. And it has to be in a whole community area, because maybe you defend your own home, but your neighbor left some fuel on the yard and it catch fire by the embers, and then the system you have might not survive because very close wooden house that is burning in hundreds of degrees, hard to be protected from that. And I think we see it from the picture from before. You see the whole area was burned, nothing like atomic bomb, nothing was left. So that's why we built the company. We want to have an effective solution. We have to want it green, and we have to have it affordable twice. Acquisition of the system, and that the insurance companies, as it was spoke by other before, would recognize the risk reduction and give you a normal insurance payments. So from experience, dozens of years, you see pictures like that the house was defended by just putting water without any retardant, anything else, and the house and the trees around it survives. It was analyzed by the academy and the professionals, and the two main results that I pick from that is that if you have an effective 1 millimeter per hour rain, then it reduced the risk by 98%, by 2 orders of magnitude. The other thing is that you have to activate the system in advance. The idea is that when the embers start to reach you, you'll be soaked with water. We have done a test with our system. We checked the humidity of a tree inside, and we saw that we increased the humidity by 30% in 15 minutes. So actually the plant soaks the water from the air, not from the roots. And that was important to learn. So it's important to have a certain amount of water and to have it in advance. 3 hours in advance, it's not sensor at the top of your house because it's several horizons far from you, and you have to have something else that will advise you. So that's the problem. The reservoir, the pump, and the main line, and the lines to the home, all designed for showers in the morning. When there is a real fire, the demand is order of magnitude more than that, and that everyone is using it, as was said by previous people before, and that's the experience around the world. Every time there is a cry, whoop, there was no water. No. In your case, maybe there was no water also, alphabet in the reservoirs, but usually what happens is that there is water, but the pressure collapses. You open so many holes that the pressure just drops, and that's the problem. And if you have the ability to control the system on the limit and not let it reach more flow than it can, then you can have a solution. And that's how our solution works. So we put on top of the buildings, we put what we call rainers. It's water guns, effective to 80 feet, a very strong flow, and it gives more than 2 millimeters per hour capability. And it has our controller that is controlling with the cloud and send telemetry, what is the situation of the pressure and other parameters. And the cloud has our patent algorithm that decide who is working when and control the pressure. And that is a very dynamic situation. I'll show you a graph how it looks in real fire. The pressure of the distribution system behave crazy. Peak to peak is 4 bars. And we managed to control it in this very dynamic situation, and we already have operational experience with fire that occur this April and May. So we also have a tactical display that shows the situation. We have the risk level, where it's coming from, so people can be aware in advance that there is a problem, but there is one that is controlling it, and the system actually can be activated automatically or manually by the people. This is the way it works. This is my village. It started because I was defending my home and my street. That's how it started. I want to keep the trees near to my homes. I like the birds that are landing 4 meters from my window with a study, and I wanted to keep it. So it doesn't follow exactly with the parameter that you have to clean from trees as it is recommended. So that's why we invented this system. So whenever smoke is detected, then the system is activated. In United States, when you have forgot the word, when you have to leave your home, it's a good cue for us to start to activate the system.
Evacuate, you mean?
Correct. Okay, I missed the word.
Got it. Thank you.
So when it works, then the controller you see it's each time it's different dome, and the domes that you see here, actual building that have the systems. This is all, it's a kind of a drawing, but the buildings that are protected are actually active and operational today in my village. And in the first phase, we do the maximum rate of flow we can to get resilience. That happens after 15 to 30 minutes, pending. And then we can reduce the amount of flow. And now fire engines can come and other people can activate other systems that protect them. And we can share more the auto distribution. We don't take so much out of it. The last phase is the impact phase. Now, usually there won't be people around, and you see exactly, you can focus exactly where is the impact, and now you can put the most of the water there, and you can, for example, skip the right side where now you see it's not under risk. So what we're selling is not only the hardware. Actually, if you can see, this box is our hardware. And we have it has independent electricity power by solar and battery the battery can stand for intense working for a week. And the communication is also by itself. Current time we have solar, but we're going to have satellite communication, and we are going to have ability to communicate between the box so they can be autonomously without communication with the out world. So what we sell above more than the hardware is the process. So the process is analyze the area, as was shown before. We also take about mile around. We speak kilometers, so that's 2 kilometers. And we see where is the fuel and where the threats can come. Then we prioritize the community, which to be defense first and which later, because sometimes the money comes from public sources. So they don't give all the money for everything in the beginning, so we can start from phase by phase. This village is in the entrance to Jerusalem, so we have done this phase, and now we are doing the yellow phase under installation. So we understand what is needed. Then we analyze the water distribution system, and we see what it can be available, and we check if what we want to defense can be really defense. When we see that it's okay, then we're happy. And as I said, we checked tens of communities, and only one place we decided we can't go there because the actual system as it is today is not sufficient. What we do on top of that, and that is not done in firefighting today, we actually run the system in its full volume, in its full flow, 2 times a year. Like an elevator, we check it, but we don't check it by checking what it runs and checking the pressure drop. We check the whole system. In my village, the normal consumption is 30 cubic meter per hour. We activated the system. We brought it to 250 cubic meter per hour. You can't do it if you don't have system like us. And we do it for 2 minutes, 3 minutes, and we see what happens. And we found a lot of phenomena that you don't see if you do the test. Now, my background is aviation.
David, only about a minute left. Sorry. So we can have time for Q&A. Okay, about a minute.
Okay, so, and that is not done today, and that's important. So just to show you, this is operating during fire risk in a village in the way to Jerusalem. So look how the pressure is jumping like crazy. And what you see, this circle, is when we activated this specific rainer. So we were managing it nice, that when we activate it, the red line is the minimum. But when we activate it, we were twice as the minimum required. So we are operational. We are operational 4 villages. We had already experience in real fires going around us. We have very good communication with the firefighters. So for 1 minute, I'll go about Palasidas. So this is the summit. You have a very good reservoir at the top. And let's see, we want to defend this closed community. 26 buildings were burned there. To defense, we need 68 rainers. The cost to bring it up is 300,000. and per building is about 4,000. Very affordable. And the cost per year, because we have expenses during the year, is also not much, 30 for the whole area, 30,000. So 10 years cost is about $0.6 million. Now, if you want to do the same thing with, you want to wet the same defensing amount of water with fire engines, you need 62 fire engines, assuming the pressure collapse. And that will cost you $240 million. You'll never have them, and that's the problem. So if I make a comparison between the methods that are effective today, so we have a very good solution that in $1 million, less than million, now it's speaking about all this area, before we speak only the above one. So for all this area, it's less than $1 million, and it's uncomparable to the other solution of fire engines or fire bombers. Black Hawk is the best helicopter now, best method. So even with the best helicopter that you don't have in California, it's still, you will never have such amount of money put on this kind of things. So very affordable, and we give a total solution with no risk. Definitely you need these sources for other things, but for firefighting, for the community, that's the best thing. I think with that, also for Aleph Bet, you have a lovely reservoir that I understand and I learned from you that it's not in use for 10 years maybe. So we've done a study of this one. If this reservoir was available, then it can defend all the alphabet area. So if you want to have 2 millimeters per hour, you can defend the red area. And if 1 millimeter, as it was recommended, is sufficient, you can defend all this area. And it would cost you per home, it will cost you $3,000. Very affordable. And what is good about it, that you know the whole community is defensed. So it's not that your neighbor will start a fire for you. I think with that I finished. So just we are operating in 4 villages. We experience real fires, and we saw that our system works okay with them. And the next things we want to go to California, and that's still ahead of us.
Well, thank you very much, all 4 of you. Thank you, David. We're going to launch into Q&A, but David, I have a question for you. Your system largely relies on the municipal water source. And so I'm wondering if a community like ours were to, let me get your video off. If a community like ours were to collaborate with a system like yours, and you obviously would have a partnership or some sort of operational agreement with our municipal water source, which would be LADWP. Do you think that you or an organization like yours would then be monitoring those reservoirs and making sure that they are in fact full? Because again, a system like yours would not have been able to be effective in the last fire because our reservoir turned out to be empty.
Very good question. Definitely yes. We must. So we go backwards to all the logistic, where the water is coming from. Somehow my picture vanished. I don't know why.
Yep, there you are. Oh.
I don't know when. Okay, so we analyzed backwards where the source of the water until we see we have capability for 1 day or maybe even 2 days of water. So yes, we need the collaboration, this water system, and what we bring to the table, what is not done in any place in the world, that we'll check it twice a year. We'll activate the system in the full blow, and we see that it works, and we give a report to the citizens.
So you would be an element of that water source monitoring.
Or like, so we use the current infrastructure, but in a more responsible way. I mean, you wouldn't let an aircraft to fly without checking it each time. And what happens with firefighting, no one is checking it.
Okay. Thank you so much. We're going to go into Q&A. Everyone can raise your hands if you want to. There is a question in the chat. I think, Daphna, that was for you in the beginning. Is there communication between your launcher and LAFD or the fire aircraft to prevent an accident? So is there communication?
Yes.
All of you can answer this because you're all somewhat remotely moderated.
So for us, the system is on the control room, and the indication whether it's active or not is known to the firefighters. On top of it, the safe mechanism of the sensors know how to spot humans, aircraft, animals, cars, and when there's one of them in the vicinity, it pauses automatically.
Okay. Jesse, I'm going to ask you, Jesse and Chris, this one is for you. There's a question in the chat. Why does IBHS not include any spray retardant or water spray in its rubric? So in order to be code compliant in the modern day, why is there no such provision? And I know both of you have been either talking to or working with insurance. Can you guys tell us the insurance reaction to this kind of deployment or system? We'll start with Jesse and then Chris. I know you've got something to say about this too.
Sure, sure. On the IBS, unfortunately, governments are reactive, and this is a very new tech, and it's incredibly progressive. And so I really don't think there's any way to define regulations around what's being installed and how effective it is. One of the big insurance reduction products or insurance reduction certifications we can get is called an FM certification. It takes about a year and a half to get, and that puts you into a risk reduction category for insurance companies. And so we're in the process of making an application for the FM certification, and it's nationally recognized standard. In the meantime, I think Chris is doing a great job. We're also speaking to insurance companies in the California Fair Plan with the hope to bridge the gap between sort of right now, 9 of the major insurers are not returning to California with fire risk riders. And so working with the California Fair Plan to fill the gap at the $3 million coverage limit to whatever the home value is, if a person is or homeowner is required to get the Fair Plan or can't find an alternative insurance product, is pivotal to having a fire resiliency product on the house, on their property. And then with private insurers or reinsurers, it takes time to become a company recognized product. And so there's brokers and there's local insurers, which are wonderful. But you have an entire state or entire region or the entire West Coast, west of the Rockies, for instance. It's more of a global reach in order to access executive C-suite teams to become a product that will reduce the risk.
Okay, and just so everyone knows, we at Palisades Recovery Coalition are working on insurance roundtables. We've had one where we talked to regulators, but the next one is going to be exactly what you're talking about. It's going to be the insurers and the risk assessors at the table to talk about what it looks like to have a more insurable Palisades. Chris, you also have been looking into insurance, so I want you to sound off on this, but a question for you. We've learned that pumping systems, so systems that pump water, if they're not grounded, if they're truck mounted or they're mobile, they do not count. So insurance companies will not acknowledge or recognize those as fire protection mechanisms. They actually have to be grounded. Are your pumps grounded because you have that pumping system that then pulls from the pool? Are those grounded?
Yeah.
Is that something that insurance will
Yeah,
recognize?
so ours is completely grounded. It's installed similar to like a swimming pool equipment set. So it's going to be a permanently installed fixture. We don't put hoses in the pool. We either get in there when the pools are being built and have a line directly into the pool, or we attach to the existing pool equipment to pull water from that. And then our tanks are usually cisterns in the ground. So nothing that we have is mobile that would be used to move around the property. And from an insurance standpoint, I just returned from a private risk management association event, and we were specifically called out for a company that can help with these brokers and carriers to think about reinsuring in some of these high risk areas that, like Jesse had mentioned, that a lot of the carriers weren't very interested for a long period of time. It's a slow process. Why IBHS doesn't do it, why the government hasn't really mandated it yet. Everything is just a slow process when it comes to those types of organizations. So we take it on upon ourselves to create the best solution ahead of those getting, the laws being implemented or some of the insurance companies. But in the last year, the insurance has come around almost full circle, where originally they weren't really recognizing what we did as important. Now it's something that's almost mandatory for them to even want to write a policy. So you have to do all the layers. You have to do the vents, the gutter guards, the fuel mitigation, and then like an autonomous system, adding those into it will make it more feasible for an underwriter to write a policy in an area that's previously been denied over and over again. So what we're seeing is a pretty good turnaround on what the insurance industry is looking at to be able to insure a property like in the Palisades that had such devastation.
Okay. That actually brings up an interesting point. You had something that protected eaves, right? And we're told that to build in the modern day per code, we need to stay away from eaves. So I'm assuming there's going to be I'm assuming we're looking at homes that are going to be built, at least in the Palisades, that have no eaves, right? More
You
homes.
probably have an enclosed eave or a soffit instead. And still, what we're worried about mostly is even if you put a sprinkler nozzle in the eave, it's not necessarily protecting the eave above it. So what we do like to do is spray our fire retardant sprays. It's a green fire product called Pro Defense. It will protect wood eaves. But in new construction, when we're doing our nozzles, a lot of it's to protect windows in the more vulnerable parts, especially when you're building a more hardened home moving forward. Usually you won't have exposed rafter tail wood eaves anymore that's susceptible to fire. So what we're doing with our nozzles is kind of creating a barrier that's coming down the sides of the home, trying to protect the most vulnerable areas.
Okay, perfect. I'm actually at PRC headquarters, folks, which is on Sunset Boulevard, and people come in and ask us what we're doing. So I was explaining. I appreciate that. Any one of you can answer this question. We at PRC have advocated for cisterns. Again, informed by the last fire and the fact that there was not enough water, whether it was just because the reservoir was empty or because the pumping technology wasn't there. As David said, there was just too much demand, and so nothing was trickling up into the hills. We have begun to advocate for cisterns. So as people rebuild, we're talking about catching rainwater, storing that in cisterns above or below ground so that we're not drawing on anybody's water source, and that, naturally just by rain, we've got water that can be used to defend perimeters. It's slow traction, as you guys, the two of you who've been dealing with insurance, know. My question is, why? Or have you talked to insurance companies or lawmakers? Is there a way for our community to come up with best practices so that as people begin to build, they can incorporate these cisterns into their construction? It can't be that expensive. It probably is something you guys can use. What do you think of cisterns, rainwater capture, and who do we start with?
Well, I think cisterns are extremely important, especially with the water situations and low pressure, and the way that the water's managed during a fire needs to improve. So adding cisterns in the community, I feel, is going to be very essential to overall wildfire protection, fire protection in that area. So moving forward with that, I feel that when you're rebuilding in these areas, designated some area for cisterns, I feel would be super important. However, they will need to be very, very large. So you'd have to find the areas where we could, you could install them to be able to have enough volume of water to make any difference. So that's kind of the main concern when people are worried about views in their property.
Right.
Adding cisterns in their view path isn't
Right.
usually the ideal situation. So
Okay.
I think finding location.
Got it. Jesse, you've been talking to lawmakers. I want to know if any of them respond to the idea of cisterns. Also, David, I think you said 1 millimeter per hour goes a long way in defense. So if somebody can quantify how big is big, that would be great. How big a cistern? Jesse, lawmakers, do they listen to you?
Yeah, they've been incredibly receptive. I think for the first time in our history of fire resilience, people are open to listening and know that something needs to be done to prevent this again. So
Okay.
yeah, on top of that, the amount of money right now, the California Fair Plan is fundamentally insolvent. $750 million or so are available. 6 billion, several billion dollars in claims. And so there's a massive delta between the amount of money needed to recover and rebuild the Palisades and all the Malibu fires and Altadena. And so there's a government push to invest in rebuilding and home hardening so that the government doesn't put themselves in a position to have to cover the gap between claims and available
Right.
capital.
Ideally, people would
I
not.
can give
Yeah, David, go ahead. I was just going to say
I
ideally
can
people
give a
would
number
not
that he
be.
was asking. It's between 40 cubic meter and 80 cubic meter, and
Mhm.
it's hard to install it in the, for example, in alphabet area, you don't have this place.
Mhm.
Then you have to have energy to pressurize it. So it's not straightforward.
Got it.
I think using the infrastructure in a more responsible way and controlled and checking it all the time and have a transparency for that, that's a good solution. But of course, it has to be integrated with the water supply.
Can I just say
Got it.
one thing? The low-hanging fruit for on-site water cisterns when you're limited on resources and site location is underneath the garage slab. It's your lowest point on the property. All the drains will go into an underground cistern. For us, if we had a 20 by 20 garage, we would need 4 feet of depth to get enough water to cover a 7,000 square foot house. It's on
So that
site.
would be 20 by 20, 4 feet deep.
Correct. Or, if it's 10 by 20, double it. But sure, 20 by 20, 4 feet deep is enough water for our system to run. Or for about a 60 by 100 square foot house for coverage for 40 hours.
Okay, interesting. Daphna, I have a question about your system. It looks very industrial. It looks like a big solution. Is it specific? Can it be deployed for specific homes, or is your solution more envisioned for that 100-acre perimeter community?
So the current system is quite big and it's not mobile and it fits a community. You would find a place that is public, it's on the side or in an area where there's no homes. Like I said, it would come with the cover that looks like a utility room, and it will sit there just like a small infrastructure. The next version is going to be mobile and smaller. No, still, I wouldn't say it for individual homes, but definitely can be moved around by firefighters or by the community as well. This system is really to give resilience to a community as a whole, to allow a community to make sure that it's not like I'm defending my house, but the house next to me chose not to go with some protection on the roof, and I get the repercussions of that.
Got it. And I think you said every one of your systems protects, tell me again, 40 acres?
70 acres, about 70 acres.
70 acres. So if you translate
Yes.
that, let's say to a Palisades community, let's say every home is on an acre. Tim, am I correct? Every
Yeah.
home is on an acre or less than that? Less than that. So you'd be protecting
No, the
100
ones I saw were much less, but you need to take into account the roads and I don't know if there's a small kindergarten or a playground or whatever, right? It all comes together. But 70 acres could be some. We saw up to even 200 homes in some areas. And again, then you would find the right places to locate systems. You need to take into account the topography as well. We don't need a clear line of sight, but we need to plan it smartly. So it could be that you'll have more than a system and a half for 70 acres to make better protection, or you'll add measures on the sides, areas that are less approachable.
Right.
And
I
this
was
is
thinking,
something that is planned by us the minute we go into a community or a neighborhood or a city.
right. So hillsides would have a different treatment than flat areas, I assume.
Correct. It's the same mechanism, it's the same system, but it will influence the location of sensors more than anything else because the launcher launches pretty high. It can go over a hill and it doesn't need a clear line of sight, but you'll need more sensors on both sides of the hill.
Okay. Last question from me. David, you said getting an early start is important. So let's say a fire like the Palisades fire that just happened, an early start would have been, and it was a high wind day. The fire drove fast. It was unpredictable. I don't think anybody could have told what direction it was going to go, which is why there were people who evacuated out of the village and didn't take a single thing with them because they were sure they'd be back the next day. So your system would have suggested to start moisture before we even knew there was a fire just because it was a high wind warning day? Would that have been the case?
So our villages developed their own tactics. One village that is very smart guys there, they decided that in critical days, in high risk days, they will activate the system for several cycles even before. But another thing they learned that they don't hesitate. When the fire is coming, it doesn't cost anything because we don't have retardant. It's not costly. It's water.
Real estate professors pretty well.
Sorry, I will find whoever that is and mute them. Keep going.
And they activate the system very early and for a long time, and it doesn't. It's not costly, so they don't have problem. Yes, so you have to. It's good to activate it 3 hours before. I think it's a good recommendation. They've done it even before because everything is then saturated with water, and nothing can be burned. So it's avoiding the ignition.
Okay, wonderful. Josie, that's good. No worries. There's a little bit of an echo, folks, because there's someone in the room, but that's okay. We're almost done. If there are any other questions, I don't see any hands raised. If there are questions, please let me know. If not, I thank all 4 of our presenters. I will make this video available for everyone to see in the community. I'll send it to all of you guys. This was incredibly informative. Thank you. As I said again in the beginning, this is just the start of the conversation. I think we are just beginning to be informed by people and companies like yours. I think we will have a Fire Tech 2.0 because I'm already getting people who are pinging us about having another presentation. I really appreciate that you guys are leading the charge on this. Definitely, the tip of the iceberg, leading the technology to save us all. So thank you for keeping an eye on resilience. Thank you for interfacing with the insurance companies, the lawmakers. Daphne and David, thank you for staying up late for us in nations or in a community that's already experienced what we've experienced and that you've come up with solutions. So I thank you all again on behalf of the Palisades Recovery Coalition. I will see you all again soon. I'll send the follow-up video and follow-up questions. Thank you all.
Thank you.
Thank you.
Thank you, Miriam.
My pleasure. Hey, Ariel. Bye, everyone. All right, ladies.